In today's lesson, you are going to learn about the zero index. That is, what is the value of a term when the index is equal to zero? I'm going to skip the rule here first and just take you through a couple of examples so that you can generalize from the pattern what must happen. Let's have a look at the first table. We have our bases equal to 2. The first one is 2 to the power of 4. If you've got a calculator, you can use that to check what the value is. Now, 2 to the power of 4 is really saying 2 times 2 times 2 times 2. Okay, and that is going to be equal to 16. Now, 2 to the power of 3 is that multiplied itself 3 times, and you'll get an answer of 8. Similarly, you have 2 squared is 4, and we can start to see the pattern that's created here. Now, each time you go down a row, you're actually timesing by one less of itself. So here, as we are multiplying less and less 2's, you're reducing it by 2 every time. So it's being halved. Okay, so what do you think would happen if we take 2 to the power of 1? Now that means there's one of the 2, hence our result is 2. And if we keep this pattern going, what do you reckon it would be if the power is 0? What is 2 divided by 2? And the answer is, of course, 1. Okay, let's investigate that pattern with a couple of other bases. So 3 to the power of 4, that would be 3 times 3 times 3 times 3. And that's going to give you 81. 3 cubed is actually 1 less 3 that you're multiplying, and that is going to be 27. Okay, so we are 3 times smaller. Now 3 squared is 9. 3 to the power of 1 is just 1 of itself, which is 3. Based on this pattern, what do you predict 3 to the power of 0 would be? Okay, so 3 divided by 3 will give you 1 again. Let's have a look at the next one. So now we have a power of 4. So the power of 4 on a base of 10 would give you 10,000. So 4 zeros. And if you times it, if you raise it to the power of 3, it would become 1,000. And 10 squared is 100. 10 by itself is just 10. What is the pattern here? The pattern is that you're multiplying by 1 10 less each time. So that means each value is 10 times smaller. So continuing this pattern, the last value, 10 to the power of 0, we can expect that to be 10 divided by 10 equals to 1. All right, now we can see here that it doesn't really matter what the base is at this point. We've tried a couple of bases. It seems that the pattern suggests all the answers result in 1 if you take a power of 0. Now, there is one exception. I'm just going to quickly mention it here. The only time this is not going to be true is if you have a base of 0. Therefore, you can't do 0 to the power of 0. Okay, that is not equal to 1. In fact, we can't put a value to it. It's called indeterminate. Indeterminate. So we can't determine what value it is. To explain that, that would take another lesson in itself. But for today, you'll just have to trust me on that. We can't use 0 as a base. All right, continuing down the worksheet. What happens when the index is 1? So let's have a look at all the indices that have 1. Okay, you can see that it just returns the base. So you can write it is just the value of the base. And what happens when the index is equal to 0? It is just equal to 1. Okay, question 2. What is 7 divided by 7? Again, use a calculator to check yourself. That should bring you to the number 1. What is 10 divided by 10? That should be also equal to 1. And what about 6 to the power of 5 divided by 6 to the power of 5? Now, the pattern we see here is that if you divide the number by itself, okay, you each get equal share of 1. And hence, it doesn't really matter what number you have. As long as it divides by itself, the result is always equal to 1. Now, we're going to calculate this particular question using index laws. So by using index laws, we're asking ourselves, how can I manipulate the indices based on what we know about dividing terms with the same base? So here we are going to subtract our indices. What is 5 minus 5? Well, that's just equal to 0, isn't it? So 6 to the power of 0. But you can see here, we said before that this is equal to 1. But at the same time, we also showed that this same expression is equal to 6 to the power of 0. Yeah, so these two things are equal to each other because they all come from the same expression on the left-hand side. So according to your calculations, is 6 to the power of 0 equal to 1? The answer is yes. So you were able to actually show this property by looking at it in two different ways, and mathematics never lies. And that is why we can generalize this pattern to say that if you have a base that is not 0 raised to the power of 0, then the result will be 1. Question 3. By writing in expanded form, show that 9 to the power of 5 divided by 9 to the power of 5 is equal to 1. So I'm going to do the same thing as I did before, except using a different base this time. Okay. Now, 9 to the power of 5 in expanded form is 9 times 9 times 9 times 9 times 9. And 9 times 5, 9 to the power of 5 at the bottom is the same thing. Okay, so what is that actually equal to? Now remember that we can cancel fractions if we are able to divide off the same number from the top and from the bottom. So 1 9 goes from the top with 1 9 goes at the bottom. So when you do that, you've divided by 9 on the top and 9 on the bottom. Here's another pair that we can divide off. Here's another one. Here's another one. And of course, the last one, when you divide off the 9 on the top and bottom, they cancel each other out. So what you have left is just 1 over 1, which is equal to 1. And using index laws, we can show that 9 to the power of 5 divided by 9 to the power of 5 is equal to 9 to the power of 0 because we were able to just subtract the indices, okay? And that is equal to 0. And because we were able to show that the left-hand side is equal to 1 and it is also equal to 9 to the power of 0, we have basically done the second part in one go. So that's part 2 answered as well. Okay. Now let's have a look at question 4 and 5. These are teacher examples, so I will take you through them. And afterwards, you will try these questions yourself. Okay. It's very important to understand that when you do these sort of problems, you have to have a good idea of your order of operations. So your bid mass, and I'm going to write it in a different way. So bid mass, because divide, multiplication, they're on the same level. Addition and subtraction, they're also on the same level. So what is B? B is for brackets. Brackets. I is for index or indices. So that's your power. D is for divide. M is for multiplication. A is for add. And S is for subtract. And anything that is on the same level, they have the same level of priority. So whichever comes first in the expression, you will act on first. Okay. However, if they are in vertical order, it means that whatever is at the top takes the highest priority when you are performing mathematical operations. Okay, question 4a. 42 to the power of 0. According to the law that we've just learned about, any non-zero base to the power of 0 is equal to 1. So the answer is simply 1. Part B. There is a bracket around -4, so it means that the index of 0 is applied to all of -4. Hence, anything to the power of 0 is also 1. Next thing, your brackets are still there. So the brackets is allowing you to apply 0 as a power to everything. So the answer is 1. Now the next one, you have a multiplication and you have a power of 0. So which one comes first in our order of operations? If we scan down this arrow, you see that index comes before multiplication. So what that means is that this power of 0 only applies to 4. It does not apply to 3. So you will do 4 to the power of 0 first, and then multiply the answer by 3. So the first step is to say 3 times. Now that just gives us 1, and the result is 3. For question E, again, we have two operations. We've got a plus and we've got a power of 0. So again, glancing down our order of operations, which one comes first? Index comes before addition. So we're going to have to do 5 to the power of 0 first before adding it onto the first 5. So our result will be 5 plus 1, because that's anything to the power of 0 is 1. Then our result is 6. Okay, I'm going to speed up as you get used to seeing this. 6 to the power of 0 is 1, plus 5 to the power of 0 is 1. So 1 plus 1 is 2. Okay, then the next one, You've got a power, and the last thing you do is the multiplication. So 1 times 1 equals to 1. I'm going to just say here, do not use calculators for this part because you're really trying to um, learn how to use your index laws mentally. Okay, for 4H, now we're going to be doing whatever is in the bracket first because bracket has the highest priority in our order of operations. So 2 to the power of 0 is 1, and we are raising it to a power of 4. Now, 1 to the power of 4 is just saying 1 times itself 4 times, and that's going to give you just 1. Okay, question 5. Same thing. We have 5 to the power of 4. Now, the trick here is not having to calculate it because you're going to take everything to the power of 0. So something, a number to the power of 0, it's just going to give you 1. You don't even have to worry about what the base results to because you're going to apply the 0 index to it at the very end. Now, in this question, we have a power and a times. The power gets done first. 3 to the power of 0 is 1. 1 times 9 is 9. And the last question is very similar to B, except I have inserted brackets around the 3 and the 9. Now, that's going to change your question because your base is no longer just the 3. Your base is 3 times 9. Okay, so 3 times 9 is 27, and then you're going to raise it to the power of 0. Now, if you didn't know what 3 times 9 is, it would not affect your ability to solve the question because applying the 0 index means the answer will be 1. Have a go at the other questions, and remember to try and do this without a calculator.